looking at how we can apply some of what we've learned here, we're going to look at projectile motion problems. And the first one is from the chapter on projectile motion, chapter 4, I think, problem number 36 that you see here about an airplane flying and releasing something and asking where it's going to fall. First, we need to change the units. So we can find that 500 kilometers per hour is 139 meters per second. So we'll start there. Make sure you're in meters per second because you want to use acceleration due to gravity of 9.8 meters per second squared. So you've got to be in those units. And then we recognize that we've got a height of 800 meters. And the question is how far does it go before it hits the ground? Really, this x distance, right? This is what we're trying to find. Okay, so the information that we have is that y in the y direction and then in the x direction. So the x direction, we want to find x, and we can say x is equal to x0 plus v naught t. There's no acceleration in the x direction. So let me slide this down just a little bit so you can see that. So x is equal to x naught plus v naught t. There's no acceleration in the x direction, so that's the full equation there. In the y direction, we have y equals y naught plus v0 y t plus 1/2 a t squared. Or we can replace this acceleration with minus g. And so our expression can just become v is equal to v naught plus y naught, vy naught, the initial velocity in the y direction, times t, minus 1/2 gt squared. Okay, and then we can start to set up a coordinate system and go from there. So the first thing I'm going to do, you can set up your coordinate system however you like. I kind of like picking a low point so I don't have many negative numbers. Then that tells me that my initial y position is 800 meters and my final one is going to be 0 meters because I set this, here's x and y, I set my 0 down here. Same thing here, this time I'm starting at 0 because I'm starting at the origin, and then this is our unknown. So this is what we're looking to find. And so we know something about our velocity in the x direction. That's the initial speed, because when something is dropped, it keeps whatever speed it had from the point of view of the ground. This has an initial speed of 139 meters per second in the x direction. If it's just released, it doesn't have an initial speed in the y direction. And so we can just say that this is 139 meters per second. And then we can see if we can find the time, then we can find our x value. So that's a matter of finding our time. So it looks like we can probably get it, hopefully, from the y equation. So if we look at the y equation, our initial y is equal to 0, and g, of course, is 9.8 meters per second squared. So if we plug all of that in, we get that 0 is equal to 800 meters plus 0 minus 1/2 times 9.8 meters per second squared times time squared. So that's pretty straightforward. That gives us, then we can solve this. We can say minus, subtract 800 from both sides, equals minus, I'm going to say 4.9 t squared. The negative signs cancel, and if I divide both sides by 4.9, I get t is equal to 800 meters. Didn't include my units. Meters per second squared. Having the units just helps you check your answers, so it's nice to keep track of them. We also need them at the end to make sure they work. So this is divided by 1 over seconds, so that seconds would go in the numerator when we get finished. So that gives us time is equal to the square root of 800 over 4.9, which when I put it in my calculator, I get 12.7, and that would be seconds. Now all I have to do is take this and substitute it in here. And so when I put that in, I get x is equal to 0 plus 139 meters per second times 12.7 seconds. And that gives me my distance of 1,776 meters. Okay, or 1,800 meters, rounding up. And so that's how you put these two pieces together. You divide them into the x and the y components because we have acceleration in the y direction, but we don't have acceleration in the x direction.